Hello everyone, welcome all to Physics with Astronautics. So in this video we will discuss about some previous year question of JAM paper and JAM 2022 physics paper. So let's begin. And here is our first question of the session, that is, a radioactive nucleus has a decay constant lambda and its radioactive daughter nucleus has a decay constant 10 lambda. At time t equal to 0, and naught is the number of parent nuclei and there are no daughter nuclei present. N1t and N2t are the number of parent and daughter nuclei present at time t respectively. The ratio N2t by N1t is, and here the options are 1 by 9, 1 minus e to the power minus 9 lambda t. Option B is 1 by 10, 1 minus e to the power minus 10 lambda t. Option C is 1 minus e to the power minus 10 lambda t. And option D is 1 minus e to the power minus 9 lambda t. We can see in the question that a radioactive nucleus has a decay constant lambda, and where its radioactive daughter nucleus has a decay constant 10 lambda. At previous case, like at time t equal to 0, and not is the number of parent nuclei and there are no daughter nuclei present. And at t equal to t1, there are some daughter nuclei and also the parent nuclei has been decayed. So what will be the value of n2t by n1t? So let's see. And we know that the formula n2t is equal to lambda 1 pi lambda 2 minus lambda 1 n naught e to the power minus lambda 1 t minus n naught e to the power minus lambda 2 t. And again n1 t is equal to n naught e to the power minus lambda 1 t. So by putting the value of lambda 1 and lambda 2 in the formula, we can get that n2t by n1t will be 1 by 9, 1 minus e to the power minus 9 lambda t. Then a uniform magnetic field B is equal to B naught Z cap, where B naught is greater than 0, exists as shown in the figure. A charged particle of mass m and charge q is released at the origin in the yz plane with the velocity v directed at an angle theta equal to 45 degree with respect to the positive z-axis. Ignoring gravity, which one of the following is true? And here the options you can see, and this is the diagram that is given in the question. So from here we can get that the uniform magnetic field B naught is equal to B naught Z, where B naught greater than 0 exists as shown in the figure. So this is the figure. A charged particle of mass m and charge q is released at the origin in the yz plane. So this is the yz plane, and from here the charged particle is released with the velocity v directed at angle theta equal to 45 degree, and theta equal to here 45 degree with respect to the positive z-axis, and the angle is with respect to the positive z-axis. Ignoring gravity, which one of the following is true? So we know that MA, that is force, is equal to Q V cross B, and Q, and we can see that here in y direction the velocity will be V cos 45 degree in y direction cross, and B is equal to B naught Z cap. So from here we can get that the acceleration will be Q V B naught by root 2 M x cap. So the right answer will be option A. Then for an ideal intrinsic semiconductor, the Fermi energy at 0 Kelvin is, the options are lies at the top of the valence band, lies at the bottom of the conduction band, lies at the center of the band gap, and option D is lies midway between center of the band gap and bottom of the conduction band. And here the right answer will be lies at the center of the band gap. Then a circular loop of wire with radius caps R It's centered at the origin of the xy plane. The magnetic field at a point within the loop is B, that is function of rho phi z t, is equal to k rho cube t cube z cap, where k is a positive constant of appropriate dimensions. Neglecting the effect of the any current induced in the loop, the magnitude of the induced EMF in the loop at the time t is. And here are the options. So as given in the question that magnetic field P is equal to K rho cube T cube Z cap, and we know that EMF is equal to d phi by dt, and again phi is equal to B dot ds. So by cylindrical coordinate system, when we will disintegrate this, and we can find that d by dt K rho cube T cube 2 pi rho d rho, and again it has been given that the radius is caps r. So by putting it, we can find that the EMF value will be 6 pi k r to the power 5 t square by 5. So our final answer is 6 pi k r to the power 5 t cube by 5. Sorry, here this is t square by 5. And then for the given circuit, R is equal to 125 ohm, RL is equal to 470 ohm, that is the load resistance. VZ is equal to 9 volt, and IZ max is equal to 65 milliampere. The minimum and maximum values of the input voltage, that is VI minimum and VI maximum, for which the Zener diode will be on the on state are. And here are the options you can see, and this is the diagram from where we can solve it. So we can say that this VZ value is equal to 9 volt, that is the voltage across this Zener diode, and IZ max is given as 65 milliampere. So from here we can find that RZ mean is equal to 9 by 65 is equal to 0.138 kilo ohm. And again the voltage across this point will be equal to VI minimum into RL divided by Rs plus RL, and here Rs is the resistance across this resistor, and from here we can get that V minimum will be 11.39 volt, that is nearly equal to 11.4 volt, and again this IL value, that is the current across this load resistance, will be 9 by 470. So this 9 is the general voltage, and 470 is the resistance across this load resistor. So from here we can get that IL is equal to 0.019 ampere. Again we know that the IS value will be equal to IZ plus IL, that is the current through this resistor will be equal to the current through this diode and the current through this load resistance. So from here we can get that this IS value will be 84 milliampere. And again we can calculate it as Vmax minus Vz by Rs. So the voltage across this point minus voltage across this point divided by the resistance across this will be equal to Is. So by putting this value, we can find that the Is will be equal to 84 milliampere, and Vmax will be equal to 19.5 volt. So our final answer will be Vi minimum is equal to 11.4 volt and Vi maximum is equal to 19.5 volt. I hope you all enjoyed this session. So for more videos, please do like, share and subscribe. Thank you.